Okay, so this is my notes on energy and unit conversions. So there's a bunch in here. It's mainly about unit conversions, but we need to talk about energy first. Okay, so what is energy? Energy is defined as the capacity to do work or produce heat. So the types of energy that most people are familiar with are kinetic energy, which is the energy of movement, and potential energy, which is stored energy. So these two are normally pretty tightly connected to each other. Kinetic energy is potential energy is converted to kinetic energy, and kinetic energy can be converted into potential energy. So this is the idea, like potential energy is you get energy from the food you eat and it goes to your muscles. That energy is stored in the form of sugars and such, and then your muscle cells convert that or transform that potential energy into kinetic energy, which is movement, which is your muscles moving. Another type of energy you don't always hear as much about, but super important, is radiant energy. The reason why we talk most about this is solar energy. So this is the energy coming from the sun, which is then your plants are able to convert solar energy to potential energy through photosynthesis. The key thing is, the other one is the law of conservation of energy. Energy is neither created nor destroyed, only transformed. It's a fundamental law of nature. You'll hear us later talk about this also as matter is not created or destroyed, only transformed. And this is because, just in case you didn't know, you've all heard the equation from Einstein, E equals mc squared. C is the speed of light, but m is mass and E is energy. So there's a direct relationship using this equation between energy and mass, which is why we care about the law of conservation of energy, and why when we talk later we'll talk about the law of conservation of matter or law of conservation of mass, and why those two are basically the same law. Alright, so keep all that in mind. This is just background on energy. Now we're going to talk about what we're going to be doing with energy. Okay, so to do this though, we have to be able to do some math, and this math is based off of three or four things that you already know. Okay, you know that anything multiplied by itself by 1 is equal to itself. So 10 times 1 equals 10. A billion, or whatever this number is with all these zeros, times 1 is equal to the same number. Okay, or 0.001 times 1 is equal to 0.001. So you already know this. Anything multiplied by 1 is equal to itself. So that's the first rule you got to remember. So if we have something equal to 1, we multiply by it. It doesn't change what we're multiplying it. Next, anything divided by itself or an equal amount equals 1. So 10 divided by 10 is equal to 1. 0.01 divided by 0.01 is equal to 1. A million divided by a million is also equal to 1. So that's the second thing we know. So we know anything multiplied by 1 is equal to itself. Anything divided by itself or an equal amount is equal to 1. I'm going to come back to this equal amount part in a little bit. So this is another one from algebra. When you're multiplying or dividing fractions, terms on top or bottoms, cancel. So this is like simplification. Think of it as simplification of a fraction, right? If you had 3x y divided by 2y, you know that those y's can cancel each other out, right? Because you have one on the top, one on the bottom. Okay. So the other thing is, if you're multiplying all this together, so this is when you simplify it, you don't even have to wait till you end to simplify like this. Like let's say we had 3xy over 1 times 1 over 2y. Before you even put this together, you can look at this and go, okay, y, there's y on both, so they cancel each other out. So my answer is going to be 3x over 2. Okay, so that's the third thing. You know all this. You've done all this. And it's fun thing with fractions, you can do a lot of this ahead of time. So if we had 3xy over 1 times 2 over y times 3z over 1. Okay, sorry, so 3xy times 2z over y times 1 over 3z, you can look at this and go, okay, look, I have a y on top and a y on the bottom, so they cancel each other out. I have a z on top, I have a z on the bottom, I can cancel those out. I have a 3 on top and I have a 3 on the bottom, so those cancel out. So you do all of that, and it's equal to, you have an answer that's equal to 2x. Now, this, to me, is a lot easier than if we'd put it all together and had like 3xy times 2z over y3z, and then we look at, okay, z's cancel, 3's cancel, y cancel. I would rather do it all as we go and only write down my final clean answer. But it's still the same algebra, it's still simplification of fractions, multiplying, dividing by fractions. Okay. All right. The other thing is with these things we call conversion factors. Conversion factors are when you have two terms that are equal to each other. You know a crap ton of these. So most of you probably know that 12 inches is equal to 1 foot. Or maybe you know that 1 inch is equal to 2.54 centimeters. That's always a good one to know. I mean, you know some of these, like 1 mile is equal to 5,280 feet. These are all what we call these conversion factors, and they're called conversion factors. It's because when we have two items that have different units, but they are equal to each other. Why is this useful? Well, remember, a couple slides back, whenever you have two things equal to each other, or you divide two things that are equal to each other by two things that are equal divided by each other equals 1. So 12 inches divided by 1 foot is equal to 1 because these two things are the same. And if you want to do it algebraically, like we draw over here, 1 foot, remember you do it on one side, you do it to the other side. So the feet cancel, that's equal to 1. 12 inches over 1 foot equals 1. So divide this side by 1 inch. So 2.54 centimeters over 1 inch is equal to 1. Or we could even do it the other way. 2.54 centimeters, divide both sides by the same number, so 1 inch over 2.54 centimeters is also equal to 1. So I hope that makes sense. That's why we call these things conversion factors and why they're useful. Okay? Conversion factors allow us to show the relationship between two numbers, and when they're equal to each other, so that it means they're also equal to 1. So that means let's just do stuff with it. Okay? So how we use conversion factors? We're going to combine all these things together we just talked about. Anything multiplied by 1 is equal to itself. Two numbers that are equal to each other divided by themselves are equal to 1. Fractions, you can cancel each other out, and conversion factors are two numbers with different units that are equal to 1. Things we just went over. So let's say I have 3 feet, and I want to know how many inches it is. Okay. Now, some of you can do this in your head, but I'm showing you this way. This is how I want you to set it up. We're going to set it up as fractions. Okay. So we have what the problem gave us. The problem gives us 3 feet, and we know that's 3 feet divided by 1 is 3 feet. So that's setting that up as if it was just a fraction to make it easier to look at. All right. So what do we want? The unit we want is inches. So we put inches up here, and the unit that we're starting with is feet, so we put those there. We know that we can, I'm going to set up like this. That's going to get rid of us because of the other thing we're talking about, how fractions can cancel, that feet will be able to cancel out. So then we just put in the unit to go with it. So in this case, our unit is, we know that 1 foot is equal to 12 inches. So there's our conversion factor, and then we just plug it in. 1 foot, 12 inches, so 3 feet times 12. So then we look at our fraction, we see how they cancel out. Remember, if you have like terms on the top and bottom, they cancel. So if we have feet on the bottom and feet on the top, they cancel each other out. So we get rid of that unit. We now have the unit that we want, and then we just do the simple math. 3 times 12 is equal to 36, and the only unit we have left is inches, so it's 36 inches. Okay, so we have, with energy, we have several relationships between the two. So the first one, we measure energy using a couple of different units. So we have this thing called a calorie. A calorie is an amount of energy it takes to raise 1 gram of water 1 degree Celsius. So this is our basic unit of energy that we use particularly with food. However, Americans are afraid of the metric system. So what we actually talk about food, when you look at food labels, you'll actually see a capital C. It's always written with a capital C because it's actually referring to a kilocalorie. Kilocalorie is a metric unit. And like I said, Americans are afraid of the metric system. So to make up for that, we use this capital C, which is stupid. But you just got to know that when you see the capital C, it's the same as 1,000 C. Okay? One way, if you can't remember kilos, if I offered you 5K cash, how much money did I offer you? I offered you $5,000. Well, and I'm not offering any money, but just saying. So that K, that's a reminder that K is equal to kilo, which is equal to 1,000. So we have this unit. With food, the capital C calorie in the U.S. system is equal to 1 kilocalorie, which is the same as 1,000 calories because 1 kilo of anything is equal to 1,000. Then we have another unit. I don't know why I put it in this order. We also have these units called joules. So again, kilo means 1,000. So if you see 1 kilojoule, you know that means 1,000 joules. Joules is a unit we use not necessarily when we're dealing with energy that's not necessarily food. And there's a relationship between joules and calories, because of course there is. And that is 1 little c calorie is equal to 4.184 joules. So like I said, joules is just a unit of energy. And so this is, if 1 calorie is the amount of energy it takes to raise 1 gram of water 1 degree Celsius, then 4.184 joules is the amount of energy it takes to raise 1 gram of water 1 degree Celsius. We just use joules for different types of energy conversion units. But these two units, because we have this is our conversion factor. So we're able to go back and forth, but using those conversion factors. So let me show you a couple examples. Okay, this is a kind of a supplemental thing. So if you're not getting this, is something to work with PLTs and come get help. But we're gonna go through these relatively quickly. Okay. So convert 554.0 joules into calories. So again, I want you to use this format. What the problem gives you. And then we're pretending this is a fraction. We're treating this like a fraction. The unit that you want goes on top, and you're starting with goes on the bottom. So 454.0 joules. So that's what we have. I put it over 1, because it makes everything kind of line up nicely. Okay, so the unit that we want is actually calories. So I write calories here. The unit that I'm starting with is still joules, so we put joules there. Now we put in the conversion factor. From the last slide, we know that 1 calorie is equal to 4.184 joules. So I put 1 there, and I put 4.184 here. Okay, then we cancel out, remembering algebraically, you can cancel out stuff that's on the top and the bottom in fractions. We have joules on the top, so we cancel that, and joules on the bottom, they cancel each other out. We're left with the unit. So it means our answer is going to have the unit of calories, and then it's 454, again with fractions. Remember, think about simplifying fractions. It's on the top you're multiplying, so 454 times 1, and on the stuff on the bottom you're dividing by. So we're dividing by 4.184, which gives us an answer of 108.5 calories. Let's do a couple more. Okay, again, everything's going to come back to this kind of format. Convert 4.5 calories into kilocalories. Okay, so what's the relationship between calories and kilocalories? Remember, 1,000 calories is equal to 1 kilocalorie. Okay, so what did the problem give us? The problem is giving us 4.5 calories. I'm putting it over 1 so that everything kind of lines up in our nice fraction. Okay, now, what do we want? We want kilocalories, so we put kilocalories on the top. What are we starting with? We're starting with calories, so we put that on the bottom. And we take our conversion factor and we put in the units to show the relationship. So 1,000 calories is equal to 1 kilocalorie. Okay, then we're going to clean this up. Calorie on top, calorie on the bottom. So those cancel each other out. Then everything on the top is a multiply, so 4.5 times 1 divided by, and then everything on the bottom is a divide, divided by 1,000. So it equals 0.045 kilocalories. Now what's cool about this, let's go to the next slide. What's cool about this is if you have to make multiple steps, you can do multiple steps. And this is why I know a lot of you can do this in your head, but I don't care. I need you to do it this way because we're eventually going to move into problems where you have way too many steps to do it as a single problem. The whole point is to do lots of things at once. So here, we want to go from 2.5 kilocalories to joules. Now, I don't know that direct conversion. What I do know, we know that 1 kilocalorie is equal to 1,000 calories. And we know that, color code all this, calories. We know that 1 calorie is equal to 4.184 joules. So there we can go from kilocalories to calories and then calories to joules. So it's a two-step process, but we still use the same format. So what does the problem give us? The problem gives us, so we write that first, the problem is 2.5 kilocalories. I'm going to put it over 1 so it all lines up. Remember, anything divided by 1 is itself, so this is just making a nice fraction or something. Okay, so what are we starting with? We're starting with kilocalories. So kilocalories goes on the bottom, and the unit that we want is calories, so calories go on top. And then it's 1 calorie, 1,000 calories is equal to 1 kilocalorie. And we look, now we can cancel out kilocalories. So now we have calories left. That's the unit. But that's our new that's our new starting with, right? So we don't want calories though. We want joules. So we need to do another step. So now we want to cancel calories. So we put the unit there. And we want to go to joules. So we put the unit there. And now we can see that calories, we have stuff on the top and the bottom, so stuff will cancel out. So we do 4.184 joules on top and 1 calorie at the bottom. And then the units calories cancel out. We're left with joules. And then everything on the top is a multiply. So 2.5 times 1,000 times 4.184. Equal. We get that, and then the unit we wanted is joules, and so there's the unit we want. So, it's a little bit long, but remember, all of this is based on the fact that you can multiply anything you want by 1, and it's still itself. When you have two things that are equal to each other, when you divide them, they're equal to 1, so we're just multiplying. We're still following that rule. And you can cancel out like terms if they're on the top and the bottom. So that is unit conversion.